Hello everyone, welcome to your chemistry classroom. I am Adetunji, your chemistry tutor. So our returning viewers, welcome back to your chemistry classroom. To our new viewers, welcome to chemistry classroom. Please do well to press the subscribe button, turn on your notification button, press your like button, share our link and put your comment in the comment box. Now let's start the business of today. As we have all know that we are in the season of NECO and the specimen for the practicals have been released. Now today I am bringing to you a genuine question. I will call it genuine question. I'm bringing to you now a question to work with in the chemistry practical, the quantitative analysis, the titration. Now let's check it together and let's work together. This video may take us through parts. If it is too long, it will be divided into two, but let's take our time to watch from beginning to the end and also put our comments in the comments box. Now we have question on the board based on the parameters and the information given to us in the specimen. Solution A contains 6.30 centimeter cube of concentrated HNO3 hydrogen trioxide 5. We were given a particular molar concentration 15.8 mole per dm cube. That's the molarity of this particular HNO3 per 1 dm cube of solution. Solution B contains 5.5 gram of sodium carbonate and 2.5 gram of sodium trioxide 5 per 1 dm cube of solution. If we can check that solution B very well, we can see that it is a mixture of two compounds. Definitely we may want to talk about purity or impurity over there, because we are combining two compounds to make a particular solution against the acid, the solution A. Now we have instruction to follow. They said we should transfer 20 cm cube or 25 cm cube of B into a conical flask and add 2 to 3 drops of methyl orange indicator. This one is talking about. And in this video, we are not going to use our apparatus. That's the reason why this video we have a lot of parts. There will be section we use apparatus. But to start with, let's go in with it, and from there we will now turn into experiments. Now, this one will be done through our experiment. We know that our pipette will be used. You know, in your environment depends on you. If you have 20 cm cube, we use 20 cm cube pipette. If you have 25, you use 25 cm cube pipette. Whatever you have, you will use. Now, you will use that pipette to transfer your solution B, that is your base, to the conical flask, and you drop your methyl orange, that is the indicator. So, leaving that side, they said something again that we should repeat the titration to obtain concordant readings and determine the average volume of the acid used. Remember that I don't have my apparatus with me currently in this video. I want us to just first of all see the picture of what the question we are expecting in this particular NECO 2025 going to look like before we now start practicalizing it with reagent, apparatus and the likes. Now, in your own school, wherever, you must do the titration, but because this is just the beginning class for this NECO 2025 experiment, that's why I'm coming from this angle. Let me say I call this place solution. I will call this place solution. Permit me to do something. What are the things I want to start working on the information given, because I may still want to use this side of my board to utilize very well. They said we should what? Repeat the titration to obtain the concordant readings and determine the average volume of the acid. The theta value I want to use here is 22.5. So I want to prepare a table towards 22.5. That's what I want to do right now. But before we do that, they give us equation: sodium carbonate plus hydrogen trioxide 5 to give us sodium nitrate CO2 plus H2. If you check very well, that particular nano 3 is not visible in our reactant of sodium carbonate. It's not visible. The reason for that will be told in the question. Alright, now let's prepare the table. Let me use this to prepare my table. Okay, let me prepare my table here. I want my volume of base. I will say volume. That you need to list out whatever you have. All these things to gather mass. Volume of pipettes. Don't call it base, just call it volume of pipettes. I'm using 25.0 centimeter cube. I'm using 25.0 centimeter cube. Alright, for my again, I'm working on the information given to us. Now let's check again what are the given parameters. Checking, since I want to prepare my table, but before I prepare my table, I can also check my parameters. Do I have anything I can write to put to gather marks? Let me check. I have indicator. The indicator mentioned is methyl orange. Let me now prepare my table. I will have my, let me draw. Please, if you are writing the exam, you are a candidate as you are writing the exam, please do well to make sure that your table is very neat. No alteration, no painting. So, to have that mark very well. So, I have my direct reading. I have my direct readings. Yes, I will have my rough title. You must put units. All this matters. I want to use three values. So I'm having first title in centimeter cube, second title in centimeter cube, third title in also centimeter cube. I want to, like I told you, I'm using the title value 22.5. So I'm working towards 22.5. So my final reading, my initial reading, final reading, initial reading. And likewise, I will create the place for the volume of the acid used. The volume of the acid used. The volume of the acid used. My rough title, I can just pick any value. Let's I put some 40.0. Let me just have 3.0 here. So here I'm having 37.0. I'm not using it. Now, I'm working towards 22.5. Let me start with that, 22.5. In your own school, in any way you're writing an exam, you will do the experiment, you will titrate, you get that value. But because of we want to work on the information, we want to start working on the information before we turn it to practical or putting the experiment together. That's the reason why the video, this first video is appearing like this. Now, we have 32.50, so we have 32.50. My initial value, 0. That is reading from the beginning. I have achieved that one. To achieve the second one, from where I stop, I want to achieve 22.60. I want to achieve 22.60, and definitely if I add up 22.50, if I add up 22.50, definitely I'll be having 45.10. That is my final year 45, and likewise we subtract, we get this value back. Now lastly, if you check, by direct is 50 centimeter cube, there can't be any initial. Then we now start again another initial. I want to pick 22.40. 22.40, I still make my initial 00. I still have 22.40. With this now, I have achieved my volume of acid. If you like, if you have pencil, you can put there. If you like, and leave it, since this is your focus to get your tighter value. Remember, if you check my value very well, the difference between them is not more than plus or minus 0.2. That's the range. Now I want to get my average tighter value. I want to get my average tighter value. Now, to get the average tighter value, average, I'm picking the 3. Average tighter value will be, I'm picking the first tighter plus second tighter plus third tighter all over 3. So what's my first tighter value? I have 22.50. plus 22.60 plus 22.40. Everything divided by 3. Please don't jump any step. You are looking for mark, so don't jump steps. You don't know the one that will be in the marking guide. So I want to add up 22.5 plus 22.6 plus 22.4. Here I have 67.5. 67.5 0 over 3, and at the end of the day I'll be having that 22.50 centimeter cube. Volume of the acid used, the average total value. That's your volume of acid that you'll be using in your calculation. That's your VA. Now that one is settled. With that said, we have answered the question here. Now they gave us equation, and let's check if the equation is balanced. Sodium 2 here, sodium 2 here, carbon 1, carbon 1. Checking it very well if it is balanced. And what's the ratio of the base to the acid? The base is 1, the mole is 1 for base, the mole for acid is 2, that is 1:2. NB 1, Na 2, number of mole from the equation. All these things we are going to use to do our calculation. I believe this one is clear, because I will rub it off so that I'll still be using my information. I will need to rub it off as I'm moving to the information, because I want to start, except from the information provided, calculate the concentration in mole per dl cube of HNO3 in the solution. They give me formula. This is the dilution formula, and let's see how it goes. Please don't miss that I've already gotten my VA, my volume of acid, as 22.5. I need to write it somewhere. All the parameters that I have, I'll put it somewhere so that I will not miss anyone. Remember, that is, I have achieved my VB, volume of base, as 25.0 centimeter cube. That's what I'm using. And my VA, the volume of acid, I have achieved 22.50 centimeter cube. I think that's a very crucial information that I need to keep to drive this down. Now, moving to this D1, they said we should use this formula. That is, I should use C2 equals to C1 over V1. C2 equals to C1 V1 over V2. Now, the next thing, what is my C1? Let me go back to the information. What is my C1? What is my C2? Maybe I should write, okay. What is my C2? That's what I want to find. What is my V1? And what is my V2? What will be the information given to us? HNO3. This book is all about HNO3. This is my C1, the molarity of HNO3. That is the C1. That is 15.8 mole per dm cube. And they gave me a particular volume to set it with. But no, they gave me this. The solution A contains 6.3. Now, this is the volume for this thing. The volume given to me is 6 points. That is for V1. They gave me 6.30 centimeter cube. I need to convert my centimeter cube to decimeter cube. That is divided by 1000. Because of accuracy, let's use calculator. So we have 0.0. We have 0.0063 dm cube. That one achieved. Now for V2, that is in for 1 dm cube right now. 1 dm cube. That is 1 dm cube for 1 dm cube. For 1 dm cube. And with that one now we can move forward. Say C2 equals to 15.8 times 0.0063 over 1. Its calculator, I believe we can achieve something and get the answer as I'm using a calculator right now. So I got 0.0995. You know, my number must be 3 decimal, but this is 4 decimal. That's what I can do. Let's approximately, I have 0.10 mole per dm cube. That one achieved as well. Approximately, I have achieved this and I've answered their question. Once you have your information and you can interpret the information very well, the work will be very simple. There's nothing in this world that is difficult that the power of God cannot solve. No matter, let the question be plenty. As long as God is giving us the wisdom, we'll be achieving it step by step. We have achieved that, we have achieved that. We are moving to this one. Calculate the numbers of moles of HNO3 used in average volume of the acid or from A, that is this acid that we have gotten here, and that is my VA. We are trying to my VA calculate the number of moles of HNO3, that is the acid used in the average volume, that VA I got. So let's work it out. Let's see if my space here can contain it. Now, that is, I'm solving this question to find, to find the number of moles. To find the number of moles, I will be very glad to, maybe I should divide this thing. So we have no space. I have my VA, the volume as 22.50 centimeter cube. And I have my concentration. They gave us a concentration somewhere. Where is that concentration I got? Okay, the concentration I have here, that is my CA, the concentration. I have it as what? 0.10 mole by VLP. If you check very well, my mission is to find the mole. To achieve this thing, let's check from the unit. The unit is not the same. This is DMP, this is centimeter cube. So I need to convert this centimeter cube to the centimeter cube divided by 1000. Let's use calculator to solve it. I need to do it for accuracy's sake. So this is 0.0225 DMP. Now, what is the formula that relates volume, molar concentration, and the number of moles? That formula that said molar concentration is equals to the number of moles over volume. So I can say since molar concentration is equals to the mole over volume, so definitely number of mole will be Ca times Va, which will make me to have what is my Ca? 0.1 times 0.025. I don't know if my camera can pick it up. So from there, I think if I multiply that 0.0225, I'm having 0.00225 moles. If I want to pick it up, maybe I want to reduce it to 3. If I don't need to reduce it, I will leave it like this. My number of moles achieved. They say calculate the number of moles of which NO3 used. What we have used. We have used 0.00225 moles in this calculation. Alright, this one has been achieved. Now the next question to be achieved right now is to find the number of moles of sodium trisulfonate 4 in 25 cm cube. And they give us the molar mass of sodium carbonate 106. Here we go again. Using the information, we are working with sodium carbonate now. Now, getting back to our information, they gave us 5.5 grams of sodium carbonate in 1 df cube. The molar mass, let me put it at number 3, to find the number of moles. To find the number of moles, they give us mass concentration, that is in gram per dm cube of Na2CO3, that is 5.5 gram in 1 dm, that is 5.5 gram per dm cube. We're going to waste time. And from there, we have our molar mass. We have our molar mass as 106. Likewise, they give us a particular volume of the base as 25, which we are still going to convert later to DMQ. We are converting to DMQ, that will give us 0.0025 DMQ. Now our mission is to find the mole. Before we go there, can we still record that molar concentration is equal to mass concentration over molar mass. Over molar mass. I want to be able to be fast because of the video now. So we have 5.5 over 106. From there, 5.5 over 106, and we have something like this: 5.5 divided by 106. I'm having 0.0519 mole per dmp. Now, to find the mole, now back on the same formula again, NB equals to CB times BB. So what am I saying in the short run? I'm saying that this 0.0519 times 0.025. Please do well to watch the video very well. Don't rush. That's why I'm not rushing as well. Calm down to watch. I don't want us to miss any information. I want us to get it right. So multiplying this answer with 0.025, I have 0.0013 as my mole for what do you call it? Na2CO3. So we have achieved this without wasting time. Balance of equation. The equation is already balanced. Now this one is just a confirmation. No, they will not ask us something like this, but just for us to confirm what we are doing. This one is talking about confirmation. This one is to confirm. Because of the video, let me move to this list, and we still complete that one in the next video. But I want us to focus, because I want us to focus on this. This one is just to confirm. We still confirm that. And here, we calculate total number of moles of sodium carbonate in 1 dmp. That's a very simple question we ask us. In 1 dmp, calculate the total number of moles in what? In 1 dmp. That is, if you can watch very well, we have done that before in one of our stages there, and we're still going to do it right now. So let me move to this to calculate the total number. That is, let me call it 1 6. Is it 6 for equation 6? Okay. Now to find the total number. To find the total number of moles in Na2CO3. So what are we going to have? What's our mass? They give us mass. What's the mass of Na2CO3 in the question? They give us 5.5. And what's the molar mass of these? Molar mass of Na2CO3 is 106 gram per mole. So putting them together to find, we know most of the mass over molar mass. I'm a little bit faster right now. So we have 5.5 over 106. 5.5 over 106, so I can move to the percentage question. 5 divided by 106, we have 0.0. Like I said, I thought we have done something like this before. 0.0519. You can check where we have gotten that moles in sodium carbonate 4. Now, let's go to the second to last question. We said we should determine the percentage by mass of sodium carbonate in the mixture. Remember, I told you it's a mixture. That sodium nitrate is just to complement this sodium carbonate in that mixture. So the answer we should find the percentage by mass of sodium carbonate in the mixture. And we know whenever we are finding percentage by mass, that is the mass of what we will find by the total mass times 100. I think now I can be solving all this question. Okay, I can stop it. Let me use this, please. So what is our mass? They give us mass of sodium carbonate 5.5, mass of sodium nitrate 2.5. So we go by this total mass. The total mass. I'm solving. Let me number the question I'm solving so that there won't be confusion. Number 7. I'm working number 7 to determine or to find the percentage by mass of sodium carbonate. So I'll be having it as sodium carbonate, that is the mass of sodium carbonate. I'm giving out formula. As a student, as a candidate that is writing this exam, please don't jump steps. Don't jump steps. So mass of Na2CO3 over the mass, the total mass, that is, let me just say mass of Na2CO3 plus mass of, let me break it down like that, of NaNO3. All of them, don't mind my environment, it's a little bit, we have heavy rainfall here. So that's the reason why, in case you may be hearing a little bit background noise. So we have times 100 over 1. What is the mass of this? So we have 5.5 over 5.5 plus 2.5, or multiplied by 100. What am I saying? 5.5 over 8.0 times 100. If calculator works very well, we have something simple. I'm using my calculator, so I'm having 5. Okay, let me just quickly jump step a little bit to get the answer. So finally, I have 68.75%. That is the percentage that mass of sodium carbonate in this mixture. Now, okay, they now ask us the last question. You know, this type of practical is a little bit interesting. When I say a little bit interesting, it's teaching whereby a solution of base contains 2 compounds. Now, tell me what are those things you observe? Even normally in titration, you know, what do you observe? At your head point, when you have added your indicator, that methyl rate was observation. So I need to tell my observation as well. So I want to write my observation. Maybe I should write somewhere here. My first observation, I'm answering question C. My first observation, I'm writing my observation. What I can notice from my observation is that observe number 1. I can see that after, you know, when I put my material in there, the thing was yellow. And after yellow, after shaking, when it gets to the end point, it turns to red. The only it turns to pink. We are all correct. That is, the solution turns to what? Solution in the conical flask. In the conical flask, turn from where? Turn from yellow to red. Your own will be pink. Let me just do slash pink. And yes, the number 2 thing I can say as my observation that in my solution I can feel bubbling. That is effervescence. It shows that CO2 has been released. You know, when you open your bottle drinks, what do you feel? You see all those bubbles. That is because of CO2. So in this I have effervescence. Or I can say effervescence, if you like, body bubbling. Due to what? What caused that bubbling? Due to the presence of what? Of CO2. Write it in full, carbon dioxide. And that is how I finish these questions before us with the information given to us by NECO. We use the information given to us by NECO, the information, the number, the quantity, and from there we came up with a question and we solved the question together. I believe you have really enjoyed the class. Though the video took us long, but at least I and you, we have gained and we have learned a lot of things. That what you have learned is what matters most to me, and likewise the sources you are going to bring out from it. Please do well to go through the video again, go through it again, work it out on your own as well. That's how we finish it. But like I told us when we were solving it, I said our confirmation, they will not ask us, but we just put it there for us to confirm. So that for some people that may want to ask us questions in the comment box that why can't we confirm it? Let's quickly confirm it now so that everything will be very clear. So let's confirm now. Let's use the information. Now we have finished solving the question, but what we work on that confirmation to see according to what they say we should confirm. Let's confirm that. Number of mole that we got for B, number of mole that we got for HNO3. HNO3 we got, remember, 0.00, remember 25. mole. And for that of our base, of Na2CO3 we got also we got 0.0013 mole. Now we want to use this, we said we should use to measure. Let's say to measure that our method of calculation or relating our chemical equation, calculation in chemistry. Then we have Na2CO3 plus 2HNO3 to give us 2NO3 plus CO2 plus H2O. And with this, if the equation is balanced, 1 mole, 2 mole. Now let's assume that we want to confirm the first. Okay, let's say we don't know, we want to confirm the first one. What are we saying? That 1 mole of Na2CO3 is equals to 2 moles of what? 2 moles of HNO3. Let's assume that we want to find the number of mole of sodium carbonates. Let's say we want to find this one, which means that we have been given this one. Let's say we want to use this one right now. We want to use this one here now. So how many moles of sodium carbonates will give us this guy? Let's confirm that from here. So we have 0.00225 of this. So when you cross multiply, I have y equals 0.00225 over 2. It's my calculator. Y will give me what? Let's use my calculator. 0.00225 divided by 2. I have what I have on my approximately. I have 0.00125. Remember, I approximated to get that one. That is approximately y equals 0.001k. You just want us to confirm. That's why I decided not to put it when we are doing the question, to put it at the back. Let's solve the question and do the confirmation so it will not take time. And likewise, to confirm the second one, let's say this time around we have known this, we want to find this one. Based on the same equation again, I will say 1 mole of Na2. Let me just write confirmed now. Confirmed. Let me write confirmed. Alright, for this one, Na2CO3 to give us 2 moles of HNO3, 2 moles of HNO3. So this time around, we have been given, let's say we want to use this 0.0013. Will give me, let's say this one is S. Cross multiply again, S equals to 0.0013 times 2. If you generate that 0. What? And that's 0.0026. Very close as well. Is that 26? Yes, 26. Something close, because I approximated. So, and that's it. Let's so this also confirmed. That's what we want to achieve about this. So, which means that all the questions I have on my board, I have solved everything. I suspended this one for us to achieve the main question, and likewise now we have confirmed that all we have been doing, they are all right. And if you have any comments or any questions, please drop in the comment section. Please do well to watch all of our videos, because our videos also will be coming on it, so that we want to satisfy you, for you to get that distinction you want in your chemistry and other subjects. So here I want to draw the curtain, and I will be very glad to see you in the next video. Do well to subscribe, turn on the notification button. Bye for now.